All right, so in certain situations, we can establish a relationship between two kinds of probabilities. So let's consider again flipping a coin. It's equally likely to land on heads or tails. And if it does, it's equally likely, 50-50, then it's called a fair coin. Now, if it's not, if we have a weighted coin or something like that, then it's not going to be a fair coin. But if it's a fair coin, then it's going to be equally likely. So the empirical probability can be used to determine whether a coin is fair. So what we're going to do is we're going to actually flip a coin so many times and figure out if it's fair or not. So what we're going to do is we're going to flip it, and we're going to flip it a number of times. We're going to flip it, 10 times and 50 times and 100 times and 1,000, 10,000 and 100,000 times. And we're going to record the number of heads observed, as we can see down here in this table below. And for each of the 6 cases in the table, the empirical probability of heads is determined basically by dividing the number of heads observed by the number of tosses. So we're going to toss it 10 times. We observe 4 heads. So we take 4 divided by 10, and we get 0.4. Then we do it 50 times. So we take 27 divided by 50, and we get 0.54. Then we toss it 100. We find 44 heads. So we get 44 divided by 100, or 0.44. Then we have it 1,000 times, we get 530. So we divide those, we get 0.53, and so on until we get to, 100,000, we get 49,880. So we get 0.4988. Well, if we think about that and we rounding to 2 decimal places, kind of like we did on this last example here, nearest hundredth, what does that equal? Well, that's going to be equal to 0.50, because that 8's going to round the 9 up, 9's going to round up the 4 to 5, and we get 0.50. So this appears to be a fair coin because, at a high number, then it's close to that. Now, when we're at this lower number, it's equal to 0.4. So it doesn't seem as fair at the lower numbers, but the more we toss that coin, the closer we get to the actual value it's supposed to be of 0.5. Now, this pattern exhibited by the empirical probabilities in the right-hand column over here is looking at how the empirical probabilities and the theoretical probabilities kind of go together. So, empirical probability is going closer and closer to that theoretical probability. And this comes about because of the principle called law of large numbers. So if you do something enough times, so if we'd go closer to maybe a million, we might be at 0.4999 something, and it'll be even closer. But we're not really going to have a person sit there and flip a coin that many times. But what happens is the closer and closer you get to a super large number, the closer and closer the empirical probability will get to that theoretical probability. And so that's how that is going to work out here. And that's all I have for this section. Hopefully that helps.